Hello guys. Okay, let me see at the left chart. Yeah, should we start now? I see the 3 people. Okay, so can you hear me? So then we shall start. So what is programming? Programming is an art. It's an art of commanding the computer, the hardware of the computer, to perform certain tasks. Alright. I think first of all we have to look at a computer in a glance. A computer is computer hardware, then there's computer software. Computer hardware is the physical parts which are movable, the hard disks, RAMs, ROMs. I don't think that's jargon there. RAM, random access memory, ROM. Then ROM is the other parts. I think then there are registers. Registers are very important in programming. Registers, I can say that transient storage spaces. They are used during programming, during the processing. That's the registers. So, of telling a computer what to do, in programming you have to specify each step. So it's a sequential way of telling the computer what to do. So this is what I'm talking about programming. Yeah, in this playlist we're going to be focusing on Python, programming in Python. If you have pre-request information on any programming language, Python will be too easy for you. If you don't have any background knowledge in programming, Python will still be easy for you. Why are we focusing on Python? Why not other programming languages which are there, C++, C Sharp. It's because Python has many uses which you can use it for. It's very versatile. Even I would like to believe that most of you are maybe in a healthcare department. Use it in there. You can use it in machine learning, in the simulations. Okay, why should you program? Why is it important to program? Okay, I'll be honest with you. My main focus is not mainly to make you be a guru of programming. As you have seen, I've entitled it Introduction Programming. I want you to have basic knowledge about programming. I want you to understand how the computer does its things, what it understands, so that you can manipulate it. The goal is for you to have enough knowledge and skill to manipulate the computer so that it can do what you want. And I've seen most medical students, and I would want to say science students, most medical students, they are very anti-technology, anti-programming. I'd say it's maybe because we don't understand. When I say programming, I would like to make parallels with maybe AI. Why do so many people don't trust AI, even in healthcare? What if it does this? What if it does that? What if I'll be liable? Okay, so in this, I would like to, so that we can understand what will be really going on, so that maybe a little bit you can improve your trust issues in technology, in medicine, and in all other fields. So what is programming? Programming involves writing code to instruct computers, enabling automation and efficiency. Yeah, that's one thing we humans are not so good at, repeating the same things over and over and over and over and over again. Yeah, these things of automation, they've been there for a long time. They're the cornerstone of how we improve our way of doing industry. Automation, people can be fatigued, as you know. We don't like to repeat tasks over and over again, especially if they're the same task. But computers, that's where they thrive. So we can leave those same things to computers, maybe higher, tasks which demand higher cognitive attention, maybe, to humans, and also those which require ethical decisions which impact life, to humans. Because programming is just binary, ones and zeros, no feelings attached. But as we humans, we can maybe make a rational decision. Okay, what else? I would like to draw very big so that we can maybe start on the same page. Computers do not understand what you say. They don't understand what you type as you type it. They don't understand what's in letter A. What is the letter A? What is the letter B? What is the exclamation mark? What is the question mark? They don't understand that. However, what they understand are zeros and ones. That is what we call machine language. Binary numbers, zeros and ones. That's what a computer understands. So the computer, we have to translate what you have said. What you have said in programming terms, we call what you say, what you command yourself is source code. That is what we call source code. Then what the computer understands is what we call machine code. Machine code, that's the one I was saying, that's zeros and ones. Okay, and then on live chat, you can also ask a question. Yeah. You can also ask a question. Okay, we can also ask a question on live chat so that we can understand and be on the same page. So for that gap, there's a gap between what you are trying to say to the computer and what the computer understands. In the middle of that, there's what we call translators. Translators, we have different types of them. We have interpreters, we have compilers. Interpreters, they interpret the source code to machine code line on a line, line by line, line by line, line by line. So when it detects an error here in programming, an error is commonly known as a bug. So when you're using an interpreter as your translator, it easily picks up that error, that bug, if you're using interpreter, because you are translating line by line. So it will be easy for you to reference back to the error. Then interpreters is what is commonly used by Python. Then we have what we call also compilers. Compilers, they translate all the source code to machine code at once in a single process, in a single event. The source code is translated to machine code in a single event. This, of course, it's beneficial for something like the fastness. It's very fast. Then, but it is slow on the first time, because on the first time you initiate the program, the first time you run the program, there will be translation, which is also what happens by interpreters. So for the first time, for initial execution, it will be like same in terms of speed. Execution is just running the code, running the program. That's what we mean by execution. Then, but compilers, they have a problem. They have a minor problem, because debugging now becomes more difficult. It is now more difficult to locate the error. Okay, there's also something I would call debugging. Debugging is just a way of correcting your errors. The computer tells you or indicates to you where the error is, and you have to correct it. That's what we call debugging, the process of debugging. Debugging is removing bugs. Bugs are errors in the code. Okay, I think we're still on the same page. Yeah, that's about translators. Then let's move on. Why it is programming and why it matters. It powers software, apps, systems that drive modern life and business operation. Yeah. Essential for problem solving, innovation, and career opportunities in tech fields. Okay, these tech fields, they're expanding to all our fields, and I know many of you don't like that, but you just have to roll with it. it helps bridge the gap between human ideas and machine execution. Computers are very good at pattern analyzing. For example, I think most of you understand medicine language. I think that's where you most thrive, where you are comfortable. If you analyze maybe something like a slide in the lab using a microscope, you may see or identify some cells, some patterns, some arrangements, and in sometimes you may not be able to link those things, those subtle, sometimes the subtle differences, subtle features which you may not be able to pick up. Okay, is the slides not moving for everyone? Yeah, I think we may be having an internet lagging. Pardon me there. Okay. Now on overview of programming language, that's the slide I'm now on. I think all of you are seeing it. Overview of programming languages. Yeah, I think I've talked about many of these things. Programming languages like Python, Java, C++, provide the syntax for writing code. Yeah, what is syntax? I think most of you did languages, Shona or English, or anything of that sort, languages. Syntax is just like grammar. You know, maybe in English, you start with a capital letter. Where there are items, you put a comma. When you finish the sentence, you put a full stop. When it's a question, you put a question mark. When you're in shock, you put an exclamation mark. That is syntax. If it is in programming language, we also have grammar. There are places where you have to put small letters, especially in Python. Python is case sensitive. It is case sensitive. If you put words, and these words, maybe the intended word, the correct one, starts with the capital letter, and you put a small letter, there will be an error because it is not the same in Python. Respect those cases. So for a small letter, you put a small letter. For capital letter. Sometimes it corrects you, but Python, most of the times it doesn't. So if you, let's say there's a code print, which is used for output. Then in print, use a capital letter P for print. It will put an error. To correct it, you have just to put a small letter P. So it is very important to check which case you are using. Then, if you have to use a colon, for most of times because in Python we don't the way we terminate our blocks of codes, they're very different. We don't put something like and if, so we use the colon a lot. I think those things are also hammer them when we start doing Python, we start doing coding, or also hammer those things into. So each language has unique strength, such as Python, readability or Java's portability. Then also Python is very versatile, very good. High level languages are easier for humans to read and write. Yeah, you have to feel privileged that you're living this era. People back then they used to code in zeros and ones. You had to understand how you represent A. You have to understand how you represent plus. These days just put in A plus. It's now more easier because we humans understand what we are doing, because we use the source code which we understand. But back then it was not that easy. Then that was machine learning, that was machine code sort of. Then in the middle was something like assembly language, where there was like a mixture of high level and low level. Yeah, but you can also look it up, cool stuff. Then these days with high level languages, then low level languages which used zeros and ones, they had no need for translators, but coding was more complex. So we are privileged to live in the era of Python. Introduction to Python and its application. Yeah, I think I've tried most of these. Python's high level interpreted language known for its simplicity and readability, widely used in web development, like using IDE like Django. You can use it in data science, you can use it in machine language, you can use it in artificial intelligence. Yeah, that's now the link. The link between AI and programming gave birth to AI. So even if most of you, I know, use AI, if you would like maybe something like an application using like something like Gemini, you may also see something on the what will be happening on the code side. I know most of you just spend your time on the preview. What will be happening on the code side? You can say that AI uses programming to understand programming a lot. And automation, I think I've done justice to that. The automation, an example which may be nearer to you, is using macros in Excel. I don't know if you've used that, a macro in Excel. Supports multiple programming paradigms, including object-oriented and functional. Then object-oriented programming is a very, very big thing in Python. Definitely look at that. And that's a very big thing. Popular among beginners due to its clear syntax and extensive library. Yeah, believe me, Python is one of the easiest programming languages we ever come across. Program execution interpreters, I think I've done justice to this. Python using interpreter to run code without prior compilation. Okay, I think I've done justice to translators. Installing Python and development environments. I think we have to do a different session so that we can see how we install Python. Then there's something called an IDE, where that's the environment where you put your code, where you write your code, where you edit your code. It will be using, or its backbone will be Python. You'll be using it to edit your code, to write your code, to execute your code, to debug your code using IDE. An example is PyCharm, Visual Studio Code, Jupyter Notebook, and also something on Sublime Text or Atom, writing and running the first code. Yeah, also I think we'll do this after the session on installing Python and development environments. That's when we'll write our first Python program. Yeah, programming is cool. Basic syntax and structure, we've done this. So Python uses a lot of indentation to define code blocks, or unlike braces in other languages. Then it's very easy to use even in coding, how you declare a variable, how you assign a variable. Maybe in languages like Visual Basic, you may need 2 lines of code, or maybe 3 lines or 4 lines of code for a thing which only needs maybe 1 code in Python. Python is maybe, I would say, it is very easy in the sense also that you have to do all of the work. Some of the work has been done already by earlier programmers, which is now incorporated into the IDEs. So you can just import a class from someone. I think we'll talk about this later. Variables and data types. Yeah, that would be an interesting session which we will do. I'm just showing you some of the ground which we have to cover, but trust me, all of this is very simple. Maybe I'll just say a little bit on this variable. Just what stores data. It's a placeholder. It's like a container of data. Being a container, it holds different types of data. Maybe a container, certain container may be good enough for liquid. Something will be good enough maybe for things like stones. But in terms of programming, maybe I would say like there will be a variable which may be good enough, which is be used for integers. Integers are whole numbers, negative and positive, or which can be good enough for decimals, that will be floats, or something which can be good enough for alphanumeric characters, that will be both numbers and letters, that will be strings. Then something which will be good enough for just 2 types of data, like true or false, that will be a boolean. I think boolean will be the most important for you guys, the true or false generation. Then we have type conversion. We can convert from one variable to the other. If it used to hold integers, we can change it so that it can now hold maybe something like a string or a float. So integers are for whole numbers, floats are for decimals, strings are for alphanumerics, letters and numerics. Then booleans are just maybe true or two for data types. Then control flow and loops. I think this will not be very appropriate for maybe for a beginner session, but it's very important. This is what gives computers reasoning power. How do computers reason? These are the steps they use. They use different pathways depending on different conditions. So that will be what we'll be looking at, the if else control program. It gives computers logical capacity, logical competence. Loops is what is also very important. the ability to do things over and over and over and over and over and over and over again. That was what we call loops. They can also be called iterations. Then in Python we mostly use for loop, and the for loop has many different facets which you also look at. Then we'll also have a while loop. I think we'll cover this in our next sessions. Then we have break and continue. It's part of the control flow and loops. Then we can also have a logic inside another logic. Yeah, interesting stuff. Then functions and modularity. That's a very, very, very big thing in programming as a whole. I may also say maybe it will be the biggest institution, the biggest concept. Yeah, I can argue it's a very, very big thing in programming. We'll definitely cover this one. Error handling and debugging. How do we handle an error if it is thrown up at us? Let's say we created an input, or we created an area. Okay, let me use vague language. Maybe let's say we created an area or an object which receives data from a user. Let's say this object which is receiving data from the user is only carrying or only containing or only facilitating numeric data. Then the user, our very beloved user, then input a string, letters, where numerics are supposed to be there. If you are not handling this error, your program will crash. But if you plan ahead and explicitly tell the computer what to do if that sort of behavior occurs, that is what is called error handling. Debugging, I talked about it. So that is the error handling. We'll be trying, that's defined by try, except, conclusion. We're going to have a long journey. Buckle up. Yeah, now any questions? Don't know if there are questions. Any questions for me before? Okay. So what type of stuff can I build with Python? Okay. In Python you can build websites using something like Django, or you can build applications, or you can train even what we call this artificial intelligence, AI. You can even train those things using Python. That is the field of machine learning. Yeah, we definitely look at that. Then there are also something like control systems. Then there are simulations. There's just a lot of things which you can do with Python. Okay guys, I think I'll see you on the next one. Bye for now.